Non-Parametric Tests, a guide to hypothesis testing. Hypothesis testing is a crucial tool in statistics. It enables researchers to draw meaningful conclusions from data, whether it's from a survey or an experiment. Understanding parametric and non-parametric tests helps you choose the right method for your analysis. Understanding hypothesis testing. Testing claims. Hypothesis testing helps determine if observed results are statistically significant or likely due to chance. It allows you to test claims about a population based on sample data. Null hypothesis. The null hypothesis represents the default assumption. It's the statement you are trying to disprove, often a statement of no effect or no difference. Alternative hypothesis. The alternative hypothesis represents the claim you are trying to support. It's the opposite of the null hypothesis. P-value. The p-value is the probability of obtaining the observed results if the null hypothesis were true. A low p-value suggests evidence against the null hypothesis. Type I and Type II errors. Type I error. Rejecting a true null hypothesis. This is a false positive, concluding there's an effect when there isn't. Example: concluding a new drug is effective when it's not. Type II error. Failing to reject a false null hypothesis. This is a false negative, failing to detect an effect when there is one. Example: failing to detect a difference in effectiveness between two drugs when one is actually better. Parametric versus non-parametric tests. Parametric tests assume data follows a specific distribution, like normal distribution. Require certain assumptions about the population, such as normality. Non-parametric tests don't make assumptions about the population distribution. Used when data doesn't meet parametric test requirements or when data is ordinal or nominal. Key differences: parametric versus non-parametric. Basis for comparison. Parametric test. Non-parametric test. Test meaning: assumptions about the population parameter. Non-metric independent variables. Basis of test statistic. Distribution. Arbitrary. Measurement level. Interval or ratio. Nominal or ordinal. Measure of central tendency. Mean. Median. Information about population. Completely known. Unavailable. Applications and examples. Parametric tests. Used for continuous variables, such as height, weight, or temperature. Commonly used tests include z-tests, t-tests, and ANOVA. Z-test for large samples. T-test for small samples. ANOVA for comparing means across groups. Analysis of variance, ANOVA, test. Non-parametric tests. Used for categorical or ranked data, such as survey responses or preference rankings. Commonly used tests include chi-square, Wilcoxon, and Mann-Whitney. Chi-square for relationships between categorical variables. Wilcoxon for comparing two related groups. Mann-Whitney for comparing two independent groups. Choosing the right test. Step 1. Data type. Is your data continuous, e.g., height, or categorical, e.g., gender? Step 2. Distribution. Does your data follow a normal distribution? If not, non-parametric tests are recommended. Step 3. Research question. What are you trying to compare or analyze? This will determine the specific test to use. Step 4. Test selection. Choose the test that best suits your data type, distribution, and research question. Assumptions of parametric tests. Normality. Data should follow a normal distribution. This can be checked using normality tests like Shapiro-Wilk or visual inspection of histograms. Homogeneity of variance. Variances of groups being compared should be equal. This can be tested using Levene's test or Bartlett's test. Independence. Data points should be independent of each other. This means observations should not influence each other. Limitations of non-parametric tests. Lower statistical power. Non-parametric tests often have less power to detect significant differences compared to parametric tests when the assumptions for parametric tests are met. Less informative. Non-parametric tests don't provide as much information about the population as parametric tests do. They focus on general trends rather than specific parameters. Conclusion: choosing the right approach. Both parametric and non-parametric tests are valuable tools for hypothesis testing. The choice depends on the nature of your data, the assumptions you can make, and the specific research question. By understanding their differences and limitations, you can make informed decisions for your statistical analyses.